Hello, my name is Jericho of ETEC 101 is this class? Yes. And today we'll be going through a brief run over of our project milestone, our power supply. So initially this power supply should be connected to a isolating transformer, but we're not in school, so we don't really have that. It would be the isolating transformer would be connected to a receptacle, and then the isolating or power supply will be connected to that isolating transformer. To identify, this receptacle is upside down, but we know that the smallest side, which is the left side here, would be the hot, the longer side would be the neutral, and the middle would be the ground. However, it would be orientated that way, but sadly it's upside down, and I don't know why. But yes, so with our power supply here, the isolating transformer has a turns ratio of 1 to 1, so the secondary voltage would have a value close to the primary voltage. However, the secondary voltage is not referenced to ground, in earth and ground, that is. And we say that the secondary is floating, and therefore the person touching the simultaneously grounded points and secondary voltage cannot be electrocuted. That is why we need a isolating transformer, but we don't have one, so it doesn't electrocute us when we're testing out our PC, our power supply. So this is the connector. The longer side would be the neutral. This is the ground, and this is the hot wire, which will be connected to our isolating transformer. You can see that. This is connected to the back panel. The back panel here, the 3 prongs are inside. This is the fuse box where we put our fuse, so if any current, or actually if any voltage that were to run through the PCB would be too high, the circuit, the fuse would break the actual the circuit, so it doesn't break our components. And then this is our on and off switch. These are the banana connectors, our ground, neutral, and our live, our positive. This is our transformer, our capacitor, our linear actuator, ICs, resistors. We got, what else we got in here? Yes, our male and female connectors, which there's 3 of them. One of them is for the voltmeter, our voltmeter, which would be here. This is our selector, and this is our potentiometer. Now, if I were connected to power, the voltmeter would give me the reading of the voltage. This is a switch that goes either manual or remotes. When reading voltage, we want it flipped up to manual, and then we have a potentiometer that when we turn, gives us different readings of voltage from min to max, and that's the wires connected from PCB to the front panel. And our bottom, we have a USB type B insert. Yeah. And overall, that is our PCB. Our power supply. If I were connected to power, I would show you the min to max, but at this time we cannot plug our power supply directly into a 120 volt source. I've already checked though with my multimeter, but I got a reading of 117 volts. However, I cannot insert it though. Not recommended. I end the video with a comment and experience. Overall, I found that I learned a lot about crimping, soldering, and different connections, as well as like the different types of diodes. And I learned a lot about continuity and how to read PCBs, as well as like putting all the where to like put all the different types of connectors and diodes inside to the PCB, as well as proper soldering. And yeah, I felt this project really opened my eyes to how to like, it's like an introduction into how to do this type of stuff. So yeah, that was pretty cool. And yeah, I had a really good experience using the different types of machinery that we did to like test out our PCB and our what do you call it? Our power supply. I learned different things like the oscilloscope and the digital multimeter we got here, as well as the one inside our lab class. So yeah, it's pretty cool. Also, yeah, that's all I gotta say. Thanks for sticking around, and this was this is my project milestone. Bye bye.